Hello students. Now today we are going to discuss the voltage divider biasing with two supply. So previous classes we have discussed how to solve numericals on DC biasing of BJT bipolar junction transistors, but already I told you in your emitter bias with the two supplies both VCC and VE given, so how to find out the DC current and DC voltages. But in here in voltage divider biasing, if you will observe, there are two supplies. One is your collector supply voltage, that is plus 20 volt. Another one is your emitter supply voltage, that is your minus 20 volt. If there are two DC voltage plus 20 and minus 20 is given, if the two supply voltage plus VCC and minus VE minus 20 volt is given, or plus VCC collector supply voltage and emitter supply voltage, both supply voltage have been given, how to find out the DC current and DC voltages. In these numericals, how will you solve? Solution. Already I told you, in case of your DC biasing of BJT, like your voltage divider biasing, but in case of it has two analysis, one is your approximate analysis and second one is your exact analysis. In approximate analysis, the condition is beta R greater than or equal to 10 times R2. If this condition is satisfied, but we will not apply, we will not go for a Thevenin's equivalent circuit. The base, equivalent base of this transistor can be developed into a voltage source, Thevenin's equivalent networks. But in case of approximate analysis, there is no need to convert Thevenin's equivalent circuit, but the condition must be satisfied, that is beta R must be greater than or equal to 10 times R2. If this approximate analysis, this condition is not satisfied, then we go for exact analysis. In case of exact analysis, here in case of if there are two supply voltage is given, like is your VCC and VE, so how will you solve this type of problems? First of all, we have to convert it into a Thevenin's equivalent Thevenin circuit at the base terminal. So in here, what we will do? So this is your R1 and this is your R2. R1 is your 8.2 kilo ohm, R2 is your 2.2 kilo ohm. If in case of DC, the capacitor here, there is previously it is a capacitor here, V0. Suppose in case of DC, the capacitor can be open circuited. So what we will do to find VTH and RTH? So to find Thevenin's resistance or Thevenin's voltage VTH and Thevenin's resistance, that is your RTH. Thevenin's voltage and Thevenin's resistance. So here RTH, the voltage source should be, DC source should be short circuited, and DC source should be short circuited like this. So this is nothing but here what? This is nothing but, this is your R 8.2 and here in case of this one, like this, this is your 2.2, this is your 2.2 kilo ohm, K, and this is your 8.2, this is your R1 and this is your R2. Here like this, the voltage source should be, can be short circuited here like this. This is nothing but to find RTH, Thevenin's resistance. To find RTH here, this capacitor can be open circuited, like this 8.2 R1 can be parallel with R2. So already I told you in your Thevenin's equivalent circuit, in case of DC biasing of BJT, so how will you calculate the equivalent resistance, that is the RTH. In case of RTH, Thevenin's resistance RTH, already I told you, RTH equal to R1 parallel to R2. Here R1 is value is how much? R1 is your 8.2 and R2 is your, that is your 2.2. What is your equivalent resistance? If the two resistance are parallel, equivalent resistance is nothing but product of the resistance by sum of the resistance. So 8.2 into 2.2 divided by 8.2 plus 2.2. So using calculator, so that is your 8.2 into, that is your 2.2 divided by that is your 10.4, and the value is your 1.73, and this is nothing but your 1.73 kilo ohm. Here RTH equal to 1.73 kilo. When you are going to calculate the Thevenin's equivalent circuit, using Thevenin's equivalent circuit to calculate RTH, so if R1 parallel R2, the value is nothing but product of the resistance by sum of the resistance. So 8.2 into 2.2 divided by 8.2 plus 2.2, the result will come 1.73. Then what we will do to find, this is nothing but your to find RTH. Here to find RTH, Thevenin's resistance, to find RTH. Then to find VTH, how to calculate to find VTH. As far as DC biasing of BJT is concerned, so voltage divider biasing is most important biasing methods. When you are going to calculate the voltage divider biasing, DC current and DC voltages, if there are two supply voltages given, it is very most important problems. If there are two supply voltages given, so how will you calculate the DC current and DC voltage? Here one thing is to find out how to calculate the Thevenin's voltage. If there are two supply voltages given, your if you will to simplify this circuit, and the circuit will come like this. This is your 8.2, and here this is your plus VCC. This is your 20 volt. This is your 20 volt, and here this is your 8.2, and R2 is your 2.2. Here R2 is your 2.2, and this emitter resistance here R2.2, this plus V minus 20 volt. That means the 20 volt here there is a supply voltage is nothing but what? Minus 20 volt. Minus 20 volt means symbolically there is in a cell, the one lower terminal end is your positive terminal and upper terminal is nothing but your negative terminal, like this. This is your 20 and this is also 20, like this. And here you will calculate the VTH, Thevenin's voltage. First of all, you have to calculate, this is nothing but your R2 and this is nothing but your R1. First of all, calculate what? Current I. And here this VCC is supplied both R1 and R2 here, plus VCC and plus VE, plus 20 and minus 20, here 20 volt and this is minus 20 volt. Both voltage are given, and you have first of all you have to calculate the current. What will be your current? I equal to, that is your here minus to plus plus 20, here minus plus plus 20. So 20 plus 20 divided by, that is your total resistance is nothing but is your what? 8.2 plus 2.2, and the value is your, that is your 40 divided by 10.4. So that will be equal to your 40 divided by 10.4, and the value is your 3.8, because denominator is your kilo ohm, and if it go to the numerator that will be milliampere. So that will be your 3.84 milliampere. This is your current. This is your current. I equal to like this. Remember, this is nothing but your voltage. This is your voltage. So how to calculate the VTH? Your VTH equal to VTH, Thevenin's voltage equal to, so this voltage is nothing but your VTH. Like is your what? Plus to minus minus. So minus 20. The current flowing like this. This is your plus terminal and this is your minus terminal. So VTH value is how much? Plus to minus minus 20, minus to plus plus current. Current is nothing but I into 2.2. And the value is your what? Minus 20 plus current is nothing but 3.84 into 2.2. And the value is how much here? 3.84 into 2.2, and that is your minus 20, and minus 20, the value is your what? Minus 11.53. minus 11.53 minus 11.53 volt. Your VTH is your 11.53 volt. That is your, the value is here 3.84 into 2.2 and the minus 20, the value is your minus 11.55. The value is your 11.55. Volt. Therefore, VTH Thevenin's voltage VTH equal to minus 11.55 volt. Minus 11.55 volt. This is your VTH. If the two supply voltage is given, so how to calculate VTH and RTH? It is most important problems as far as the DC biasing is concerned. So we have already been calculated VTH and RTH. Then what will do? Then next we will calculate the equivalent Thevenin's voltage, equivalent Thevenin circuit. Like this is your Thevenin's equivalent circuit, that is your what? One is VTH and then another one is your RTH, VTH and another one is your RTH, and there is an base reader on the circuit. This is your RC, a plus 20 volt, and this is your RC, and here there is your RE, and here there is an what? Minus 20 volt. This is your plus terminal and this is your minus terminal, and this is your 20 volt. And here RTH, we have already calculated RTH. RTH is your 1.73. Here RTH is your 1.73 and VTH is your minus 11.55. RTH is your 1.73. RTH is your 1.73. This is your RTH, and this is nothing but your VTH minus 11.55. If it is minus 11.55, that is your, this is your plus terminal and this is your minus terminal, and you can write that is your 11.55 volt. Most important, if the voltage will come out minus 11.55 and this will be plus terminal and this is your minus terminal, and plus minus minus, that is your 11.55. This is your 1.73 RTH, and this is your RC, is your RC. The resistance RC is given, that is your 2.7 and 1.8. 2.7, that is your, this is your 2.7 and this is your 1.8. 2.7 kilo ohm, this is 1.8 kilo ohm, and beta already given, beta equal to 120. This is your exact equivalent circuit of voltage divider bias with the two supply. Then we will calculate applying KVL to the input and then apply Kirchhoff's voltage law to the output. If you apply KVL to the input, apply Kirchhoff's voltage law, apply KVL to the input loop. What is my input equation? Here, plus minus minus. Here current flowing like this. This is your plus and this is your minus. So plus minus minus, that is your minus 11.55. Then plus minus minus IB into RTH, minus IB into RTH, Then there is a potential between base and emitter. If the voltage is not given, mentioned, you have to take into account, there will be plus and there will be minus. So plus minus minus, that is your VB, and it is, if it is 0.3 for germanium and 0.7 for silicon. So minus VB, then current flow through the RE is nothing but emitter current, that is your minus IE into RE. Then minus plus 20 equal to 0. It is very, very important. when you are going to calculate apply the Kirchhoff's voltage law to the input, if there are two supply voltages given, so you should consider this voltage. If it is minus 20 volt, means here plus terminal and this is minus terminal. So this is when you are moving from in clockwise direction. In clockwise, plus to minus minus and minus to plus plus. In Kirchhoff's voltage law, if you go from plus to minus, consider as minus. If you go from minus to plus, that will be plus. So already sign convention is already given. Here RTH plus minus, here plus minus, and here also plus minus, entering plus, leaving minus. So voltage source, the terminal plus terminal and minus terminal already specified. So you just move from in a clockwise direction, apply KVL. If you move from plus to minus, consider minus. If you move from minus to plus, that will be plus. So here the equation is like this. So that means there is a drop, 2, 3, 4, and there is a potential 5. And there will be 5 terms, 1, 2, 3, 4, 5. You have to ensure that means there is a 5 voltage source, 5, sum of the voltage in a closed loop is 0. Then what will do? Applying KVL to the input, find the input current is your base current. So here that is your emitter current. Already I told you, emitter current IE is nothing but what? 1 plus beta times base current, 1 plus beta whole into IB, because emitter current equal to collector current plus base current. So collector current equal to beta times base current, beta into IB plus IB, that's why I equal to 1 plus beta whole into IB. So this is your minus 11.55 minus IB RTH, then minus VBE, then here in place of emitter current IE, put 1 plus beta whole into IB, minus whole into 1 plus beta whole into IB into RE plus 20 equal to 0. We have to calculate the base current, apply KVL to the input, find the input current is your base current. Here the IB, here is your IB. Our concern is to find out the base current. That's why what we will do, this is your minus 11.55 minus VB. VB take as 0.7 because in case of silicon, consider VB equal to 0.7. This minus term go to the right hand side, which becomes plus, and here plus 20 equal to IB taking common, that value is what? RTH plus 1 plus beta whole into RE, or IB equal to your, that is your minus 11.55 minus 0.7 plus 20 divided by RTH plus 1 plus beta whole into RE. So RTH is already mentioned 1.73. So RTH is your 1.73, that is your 1.73 plus beta is your 120, 120 plus 1, that is your 121 into RE. Here RE value is given 1.8. So in this calculation, using calculator, that is your what? 20 using calculator, then what? That is your 11.55 plus 0.7, it is comes around 12.2, minus 12.2 plus 20, that is your, the value is your what? 7.8, because this is plus, so 20 minus 12.2, it is comes around 7.8, that is your what? 7.8 divided by, that is your 1.8 into, that is your 121, the value is your this plus 1.73, the value is your what? 219.53, 219.53, and this will be your what? That is your 7.8 divided by 219.53, the value is your what? 0.0355 milliampere, because here are on kilo ohm, so reciprocal of kilo is nothing but what? Milliampere. 1 by 10 to the power 3 is nothing but 10 to the power minus 3, 10 to the power minus 3 is nothing but milliampere. This is the value of base current IB. So you have to convert base current in terms of microampere. So in microampere, again 10 to the power minus 3, because decimal point comes to 1, 2, 3 digits, 35.5. This is nothing but your 35.5 microampere. Your base current IB equal to 35.5 microampere. After getting IB, then usually you will calculate emitter current. IE value is how much? Or IC equal to what? Beta into IB. Beta into IB. Beta value is 120. IB is nothing but 0.0355. The value is how much? Simply you multiplied into 120. The value is your 4.26. IC value is your 4.26 what? Milliampere. 4.26 milliampere. This is nothing but your collector current IC. IC is your 4.26 milliampere. Then we are going to calculate collector emitter voltage. Collector voltage here, this is your VC. The total voltage is your what? This is your plus 20 and this is your minus 20. VC means what? From this to this is nothing but VC. From this to this is nothing but VC. Otherwise, you can calculate total, that 20 minus of this drop, 20 minus ICRC. So VC, the collector voltage, VC equal to VCC, total supply voltage of VCC 20 minus ICRC. And this is VCC equal to 20 volt, 20 IC, already we have got IC equal to 4.26 minus 4.26 into RC. RC is your 2.7. And the value is how much? That is your 4.26. 4.26. 4.26 into 2.7. So into 2.7. That is your 11.5. 11.5. That is your, it is around 8.488 volt. Because this is your greater value and this is your smaller value. So 20 minus this is your 8.488 volt. So VC value is like this. Then what? VB. VB is what? VB means with this to this. This is nothing but your VB. From this to this is nothing but your VB. Because base, this is your base. This terminal is your base terminal. This is your collector terminal and this is your emitter terminal. Base with respect to ground is nothing but a VB. Collector with respect to ground is nothing but VC. This should be this. This voltage is how much? This voltage plus this drop. VTH plus minus 11.55 minus 1.73 is nothing but your VB. So VB value is how much? This voltage, that is this voltage plus this drop is nothing but your VB. So VB equal to minus 11.55 minus 11.55, then plus to minus this is your IB RTH. IB into RTH. This is nothing but your VB. So this value is how much? That is your minus 11.55 minus IB value. Already you got IB equal to how much? 0.035. So IB equal to your 0.0355 into RTH. Your RTH value is your 1.73. 1.73. The value is how much? That is your 0.355 into 1.73. 1.73. This one plus 11.55. The value is around what? And both are minus sign, so minus 12.16 volt. 12.16 volt. This is nothing but your VB. Okay. So here we have already the question asked to find out the DC current and DC voltages. Find IB, IC, VC and VB. So IB already we got 35.5 microampere. IC multiplied with beta. IC equal to beta into IB. IC equal to 4.26 milliampere. And VC is your 8.488 volt. And VB equal to minus 12.16 volt. So here if you observe, that is your, in case of voltage divider biasing, if there are two supply voltages given, how to calculate the DC current and DC voltage in case of voltage divider biasing. This is very important problems as far as biasing of BJT is concerned, particularly in your voltage divider biasing. In voltage divider biasing, if the two supply voltages are given, so how to calculate the DC current and DC voltages? First of all, you have to convert it into a Thevenin's equivalent circuit to find out RTH. Simply RTH is nothing but R1 parallel R2. To find out in case of DC equivalent circuit, all the voltage source should be, DC source should be short circuited and current source should be open circuited. And 8.2 simply parallel with 2.2, 8.2 kilo ohm and parallel with 2.2 kilo ohm. The resulting resistance is 1.73k. And to find VTH part, how to get the VTH? First of all, you have to calculate the current. The input circuit can be converted into like this. This is a 20 volt, and here also there is a 20 due to emitter supply voltage, and there is a 20 volt. First of all, find out the current. Current equal to sum of the voltage by the sum of the resistance. 20 plus 20, 40 divided by 8.2 plus 2.2, that is a 10.4. So I is coming around 3.84 milliampere. After getting I, then lastly you can find out the VTH. This voltage is nothing but this voltage plus this drop. This is plus to minus 20 volt and plus 2.2 into current. Current is nothing but what? That is your 3.84. It is comes around minus 11.55. In VTH we got minus. That's why to draw the Thevenin's equivalent circuit, this is your minus, because this is plus terminal and this is your minus terminal. So that's why this is your 11.55, and result Thevenin's resistance already you have calculated 1.73, and whatever this out collector term and collector resistance and emitter resistance keep as it is. So that's why these are plus 20 and minus 20. Simply apply KVL to the input. You will get the input current. Input current is your base current IB. So IB we got 35.5 microampere. After getting IB, then multiplied with IC, you will get the beta IB. IC equal to beta IB. Then VC equal to what? This with respect to this is nothing but VC. Total minus this drop. Total minus this drop, we will get this one. That's why VC equal to VCC minus ICRC. Already IC we got 4.26. So VC equal to VCC minus ICRC, it is comes around 8.488 volt. Similarly VB, base with respect to ground is nothing but VB. VB is nothing but this voltage plus this voltage. That is your what? Minus 11.55 minus IB into RTH is nothing but VB. It is all about your calculation of how to find out the DC current and DC voltage in case of voltage divider biasing with two supply. Thank you.